Hello, hello, hello.
So,
Now, did you attempt this question? These were the two questions I gave you as homework. So if you did not see it, if you did not attempt this one, just tell me. Just try to read it now and then tell me you're able to understand this or not. See, it looks like this is a tough question, but it's not. It's not tough. It's very easy. After this, after solving these two questions, we'll start center of mass and rotation.
how to do it? वीडियो रिकॉर्डिंग हुई नहीं थी ना पूरी तो आई
Yeah.
जस्ट
Haripriya, what about you? Could you understand this question?
Yes, sir, but I'm thinking how to solve about.
Okay. Do you want some hint? Do you want me to explain? Means how you should go about solving this particular question? Same thing goes for Diva also. I gave these two questions as homework. If you have tried it, okay. If you did not try it, just read this one and then see what concept you are getting it. See, Haripriya, do you want me to explain this? Because Radhika wants it. Because she's
Sure, sir.
ओके. दिवा, तुमने अटेम्प्ट किया था इसको? देखा था? पढ़ा था? नहीं, कोई बात नहीं, मैं करता हूँ. See, first I'll tell you the approach. Calculation part you can do. That I'll leave up to you to solve it. Question is two identical cubes A and B. These are two identicals A and B. They are of mass 2m. For both, the mass is 2m. Side 2d. The side of these tubes are 2d. They are given. It's square tubes. Placed over one another. B is attached to one end of the spring of force constant K. This is K. The other end of the spring is attached to the wall. This one. System is resting on a smooth horizontal surface with a spring in the relaxed state. Relaxed one. Now things change. This was the system which was actually present initially. Now things change. A small object of mass m moving horizontally with speed v, this one, moving with speed v, at a height d above the horizontal surface, hits elastically the block B along the line of center of mass. They have told it's elastic. Okay. There is no friction between A and B. There is no friction. See, now what happens? Let me explain you what things are happening. See, between A and B, there is no friction. Between B and surface, there is no friction. What will happen? This mass M will collide with B. Okay. We do not know. See, we do not know. We only know that collision is elastic. This mass will collide with velocity. V will collide with B. After that, B will be getting some velocity, say V1, and this small m may be moving with some velocity V2, say. We only have one thing, that the collision is elastic. That means E is equal to 1 here. So one thing is, you can obviously use that particular formula, the above formula that I have given you. That formula I have derived now, collision one, that you can use to find out the velocity V1 and V2. One thing. Now, after you have found out the B has got some velocity, focus on this, it will try to move. But the normal thinking is A will move along with B, but won't. A will not move because there is no friction between A and B and there is no velocity imparted to A. So it will remain at this position only. There is no friction between A and B, so it will slide off. B will try to slide off. Now, there will be a situation. Now, you will think, they're asking find the velocity of V such that the block A will topple over B. Now, here is the catch. This part I thought you will be doing it, but there is a catch. The toppling condition, actually this toppling condition I was about to tell you after the center rotation, that chapter only. But here let me tell you when the toppling occurs. This is the situation of toppling. This distance is 2d. This is also 2d. Now when this B moves by a distance d, okay, means it comes halfway, there will be a situation when A will try to topple down. Means this x, what I am saying is, when this x, this distance becomes greater than or equal to d, A will topple down. Okay. Why this happens in this way? Is it okay what I told you? Why this happens? What is the concept of toppling? Mg is acting at the center. Now, in a situation, suppose this block was like this. Block B was here and it was like this. This distance, it was just this d by 2. Mg, the center was here somewhere. Mg was acting here. Suppose this is a situation. I'm trying to explain you where this toppling is occurring. Why the toppling does not occur here. Mg is acting here. Now, if you have heard the concept of torque, about this it will try to topple, but because mg is acting here, the torque will be acting this way. So there is no point this above block will topple down because mg is trying to rotate it towards the right. The concept of toppling occurs when this mg comes here, and because of the torque it tries to rotate this side, so it will try to fall down like this. So this will happen only when mg is just present left to the point O. So it will try to topple it down like this. It will try to rotate it. So for toppling, if you are able to understand this thing, what I have told you, okay. But if you are not, if you did not understand, not a problem, because you will be able to understand it after the rotation part is over. After I explain you the torque and rotation part, and then I'll separately take the toppling part. Okay. So for now, things are when this block B will move a distance x which is greater than or equal to d. For that case, this threshold case, you will take x is equal to d. Then the block A will try to topple down. So between this position, when block has got the velocity v1, between this position of B and this x, when x is equal to d, the B has moved this, you can apply the conservation of energy. Using these two concepts, you can try to find out the velocity v. Understood? Or everything went up?
Sir, I understood. Oh, sir, I understood.
Understood? Okay. Can you solve now? What about Shama? Shama, how are you now? How's your you were feeling not well, na? Yesterday?
No, also not feeling.
No, not well. Okay. अच्छा, if you have understood, Radhika, what about you? तुम्हें समझ में आया कुछ? थोड़ा थोड़ा. See, Haripriya and Diva, you have understood. Can you try to solve it? Solve stepwise. First, using your concept of using that formula that I have given you, try to find out the velocity v1 of block B after collision. Or you can use, if you do not remember that formula, because I also do not remember that formula, never try to memorize it. You can make two equations. First equation is mv is equal to 2m into v1 plus m into v2. This is one equation. The other equation you can use is E is equal to v2 minus v1 . No, I will take this. V1, this is V2. For just simple understanding purpose. V2 minus V1 by V minus 0. Since this E is equal to 1, my second equation will become V2 minus V1 is equal to V. Using these two equations, you can just try to solve the value of V1. V2, sorry. You can just get the value of V2. Solve it and tell me what value you are getting. What is the value of V2 you are getting?
E is equal to 1, no, sir.
E is equal to 1. Yes. Now, how much time you are taking to solve this? V2 is equal to 2v by 3. V1 is equal to minus v by 3. Hmm. Now see, now let's solve it further. After B, now what situation has come is B has got the velocity v2 is equal to 2v by 3. Now this will try to move and it will move up to the distance d so that A will topple then. So up to that distance we have to apply law of conservation of energy. Half 2m into 2v by 3 whole square is equal to half k into d square. This is your answer. Or more simply, V is equal to 3D root over K by 8M.
Sir, why did you consider V as here, sir? Here, V2 and V1 as, sir.
What, this one?
No, why did you consider V2 and V1 as?
Like this. V2 as V1 as?
No, sir. Velocity of which block have you considered V2 and V1?
Acha, velocity of block B I have considered V2 and the velocity of this, the small object small m, I have considered V1.
Okay, sir.
Actually, there is one one catch that you must have asked me, sir, this is B. Who is this B? Shiva, Haripriya, Radhika, Shyama. Oh no.
See, can you repeat?
No. There is someone named B trying to get into the class. I do not know if it's some of you or not.
But I guess Kanishka would be getting.
No. Kanishka said to me she has another class today. Uh, some other class, so she won't be able to join. She actually messaged me earlier. Kanishka. अरे कनिष्का, मुझे लगा तुम्हारी क्लास है इसलिए मैं तुम्हें मैसेज नहीं किया। तुमने बोला
तो
था।
वो क्लास हुई नहीं एक्चुअली, तो
ओहो।
उन्होंने थोड़ा लेट बताया कि लाइक पोस्टपोन्ड होगी, तो इसलिए आई जॉइंड।
9 बजे ज्वाइन कर लेते हैं। You should have joined 9 PM.
यस, उन्होंने मैसेज इतना लेट भेजा 9:15
अच्छा,
में।
ओके। कोई बात नहीं। मैं बस ये क्वेश्चन सॉल्व कर रहा था पहले वाला।
ओके।
You understood ना? This velocity v is how we got v. The second part, can you do it? Second thing. See, here one more thing is there. You could have asked me, any one of you could have asked me, sir, why you are taking velocity 0 here? In this situation, when it has moved by a distance d, why you are taking the velocity of v as 0 here? This part I am not considering. Because for the toppling to occur here at this point, I am trying to take, because that moment when it will be toppling, I'm assuming that this block will momentarily be stopped. After that, it may follow its path. But momentary stop, I am doing it. That's why I'm taking its velocity as 0 here. Then again, it will try to move again. Now see, let's do it quickly. The second part, you understood now? This first part first is easy. Just two things. Law of conservation of momentum, solving this, and law of conservation of energy. Now let's do the second part. If V is equal to V naught by 2, find out the amplitude of oscillation of block spring system. Now here, if they have said, if the velocity is V naught, if this initial velocity V is V by 2, then what will happen? Initial velocity V became V by 2 now. So how the answers will change? This velocity V2 will become 2V by 3 by 2. So it will become V by 3. Now the amplitude For the amplitude, how it will be, this velocity, with this velocity, if it is moving half 2m into v square, v by 3 whole square, this will be equal to, for amplitude to find, this was the initial position. This was the initial position of the spring. Now, when it will be doing its amplitude, it will be compressing fully. Full compression will be there. X max. That is called the amplitude, because it will move like this, fully compressed, then it will move again, come back, then it will move to the left like this. So at the movement of maximum compression, the V should be equal to 0. Velocity will become 0 here. So this will be, in this particular case, half into 2m in half into k into x max square. This is amplitude. So half into k into a square is equal to half into 2m into v square by 9. So half of will can cancel, 2m by 9. B value was 9d square into k by 8m is equal to ka square. So k will get cancelled, 9 will get cancelled, will get cancelled, 4. So a will be equal to b by 2. Actually, to say, see, now I will try to find. You understood this one, na? Second part also.
Yes, sir.
राधिका आप बताओ, क्वेश्चन टफ था, इजी था? Now see, now
समझ आ गया.
समझ आ गया ना? हाँ. See, now I will try to find the. See, I will now say what is the flaw in this question. There is a flaw in this question. Actually, they have said the block will topple. For that, I have tried to find the toppling distance, the toppling velocity, the velocity v, so that it will topple. But here they should have asked us to find out. Achha, wait. Not the flaw. Okay. It should be correct. Half into 2m into 2b by 3 whole square. Half k into x max square. In this question, actually, they must have told us that point, the point that should be the maximum point, the point where this d is compressing by d, that should be the point of toppling. That should be the maximum compression in this case. Some information is missing actually in this question. They should have given more things. One more thing is specifying this thing, that the velocity at this point of toppling becomes 0, because it will not move ahead after this. It will come to momentarily stop. Okay, this is how we solve this question. This concept of toppling I'll tell you later in the next class. In the rotation, last part of rotation is a toppling part. Okay, now we'll move on to the next question. This question is interesting, actually, a better one. This was easy. Actually, the earlier was easy. Study it very quickly. Try to study this question very quickly. See, let me explain you quickly. so that you will understand it faster. What the situation is, this is a small mass m which is present on the capital mass M, and this capital mass M and small mass m, they both are movable. Now what is happening, this mass moves like this, comes here, goes to the circular path, reaches here. Now when it will reach here, it will have some velocity, we do not know. At the same time, this capital M will also have some velocity because they both are movable. So what they're trying to ask, radius and all, everything is given to us. Radius, initial velocity, 10 meters per second, capital M mass, small m mass, it's given to us. Now what they're trying to ask, that when it will move, when it will come out of this trajectory, where it will fall on the capital M block. This distance they are asking. Now, can anyone suggest me what should be our process for solving?
Law of conservation of energy.
Okay. Law of conservation of energy between what point? Bottom and top point.
Yes, sir.
And in that case, half m v naught square will be equal to half capital M v1 square plus small m g into 2r plus half into small m into v2 square will be there. Too many variables. Two variables are there. One more equation we want. This is your law of conservation of energy. And mind you, let me tell you, this velocity is the velocity of small m with respect to ground. Every velocity that I have taken, every velocity is the velocity with respect to ground. This mass m velocity v2 is with respect to ground, not with respect to capital M. Law of conservation of energy, you told me, I have applied law of conservation of energy. You are correct here, we can do it. Law of conservation of energy we can apply. But problem is we need one more equation. Because two variables are
So
there.
after we find out the velocity at point D, can we use the formula of range of horizontal projectile?
You can use that. You can use. But for that, you have to find out the velocity v2. Na? And that too, see, there is one more problem. Just to find out, because it's falling on the block capital M. So you have to find out this range. You can use that formula, but for that you have to find out the relative velocity of small m with respect to capital M. Means if you are finding v2 is the absolute velocity, that means you have, for finding out the range, you will use vr, relative velocity, which is v2 minus v1, v2 plus v1, because then only you will be considering that block capital M block is stationary. Na? You have to find out the velocity of small m with respect to capital M. Otherwise, this mass m will move somewhere, and this, in that particular time, capital M will also move left. We have to combine both the displacement and then add. So simple thing, we have to find out the relative velocity. Relative velocity will be v2 plus v1. Now, if you find this, you will be, after using this velocity vr, you will be able to use your horizontal range formula to get the value of x. But again, that problem has arisen. The problem came in front of you. How do you find out v1 and v2? Because two variables are there. One equation we have got from this. What is the other equation that you will use?
The velocity at topmost point will be root gr.
How?
Vertical circle.
But here they haven't mentioned to consider the curved path as moving.
Yes, sir. It is not moving, only the block is moving.
It's placed on a horizontal floor.
They both are moving.
No, sir, but the velocity, they've not given that the block also moves. I mean, the
They
path.
haven't mentioned in the question, sir.
If you want to make it easier,
So they've given the curved
No,
part of the surface shown in semicircle. They've not given the velocity of its move.
then
they haven't.
then they could, then what's the point of giving the mass of that upper this curved surface?
It need not be to use.
No, actually, they actually see there are 2 points through which you can see that they both are moving. One is this capital M is the mass is there, separate mass is given to it. Another thing, it's placed on the frictionless surface, placed on the horizontal floor. That's they have given. It's placed on the horizontal floor, and they have not. They have told you to neglect friction everywhere. There is no friction. That means they're specifying that there is no friction between M and the surface, so the block is movable, obviously.
Can we use law of conservation of momentum?
Ah, correct. The second thing you will be using is law of conservation of momentum. Very good. The law of conservation of momentum I'll use between A and this D point. Initially it was mv naught. I'll specify the direction and let's take this direction as positive. So mv naught, initially capital M did not have velocity. Later capital M into v1 plus small m into we want VR, so I'll write VR minus V1. It will be actually, so let me write like this. Because V2 is in this right direction, no? This direction is negative. So minus M into V2. Later, because I want to get the value of VR, I'll replace everywhere where V2 is there. I'll replace everywhere V2 as VR minus V1 because I need to get VR value. Because we are using VR only, I'll be getting the value of X. So I'll replace here V2 is equal to VR minus V1. Here also I'll replace VR minus V1. So then you will have to solve these two equations to get VR and V1 separately. Now ask me if you have any doubt. These are the two questions, two equations. Very good. Shiva, you have told me this law of conservation of momentum. These are the two equations that you will be using here. Solve them to get V1 and V1 and VR. See what points you should understand from this question. Now, why I gave this question to you right now. I wanted to show you that when you are using law of conservation of momentum, na, you have to take every time the velocity with respect to Earth. This mass m is moving relative to this, but you have to take absolute velocity of this one. Absolute velocity of m. So when you are using either law of conservation of momentum or law of conservation of energy, we use the absolute velocity of the objects, means the velocities with respect to the Earth. Can you solve it? Just try to solve quickly and then tell me what velocity we are getting. Is it becoming too tough? Haripriya, is it getting too tough to understand?
No, sir, it just needs a bit of application.
I gave this question to make your concepts clear. राधिका ये समझ में आया तुम्हें?
Yes, sir.
See, I'm telling everyone, in the work power energy, only three things you will be using at max. Mostly the law of conservation of momentum and law of conservation of energy. These two are fixed. Sometimes when the question is more complex, you will be using law of conservation of energy with law of conservation of momentum, then circular motion equation. That's the most three concepts you will be using to solve every question of law of conservation of energy. So if at all a question the problem arises, you are not able to solve the question, just remember this. Apply the law of conservation of energy, framed one equation if you are getting answer, okay. Otherwise, use the law of conservation of momentum. If then also something is missing, use circular motion. The velocity VR that you will be getting, na, it will be 7.5. If you are getting it, otherwise that's I don't think I'll be start. And from us introduction only I'll be able to. is this? $81 plus 990 V1 square minus plus 40 minus 18 V1. How to solve?
Sir,
Is there any root?
no,
We have to use quadratic only. We hate these kinds of questions. One plus or minus 18 square. 18 into 18 minus 8, 10, 180. 180 9 2 4 8 6 root 5 6 root 5 1 plus root 5 by 18 3 1 plus or minus root 5 by 3 minus root 5 by 3. They're not getting. They're saying it's a V1 we are. The V1 value that we are getting is 1 plus or minus 2.23 by 3, 0.7, 1 plus or minus 0.7 something, 1.7 and 0.3. And if we use it here, we getting VR is equal to 10 into V1 minus 1. It is 10 into 0.7 means it is approximately 7. Or VR will be 10 into 0.31. That cannot be. VR cannot be negative. So this value will reflect 10 into 0.3 minus 1. So it will be minus 0.7 minus 7. Negative value we cannot. So wrong. So the direction we have assumed is correct. This VR. So this value we won't take. This value is okay. Approximately, we have done approximation. They are saying it is 7.5. We are getting 7. This is because we are not using calculator. Approximate value we have got. Okay, that works. So now we have got the velocity VR. See, this is how you should do the calculations. If VR value you have got approximately 7. Now tell me how you will find out the X. This part is easy. Part is very easy for you. Can you do quick calculation and tell me what is the value of X? This kinematic part is over now, projectile for you.
Yes, sir.
राधिका आप दिखाओ, अब स्पीड दिखा दो अपनी. ये वाला पार्ट तो तुम्हारा पूरा कंप्लीट है ना. बीआर अपन ने निकाल लिया है 7. नाउ टेल मी द वैल्यू ऑफ एक्स. व्हाट वैल्यू ऑफ एक्स यू विल बी गेटिंग अप्रोक्सीमेटली? Usually when they give these kinds of questions in advance, na, they give such kind of calculations so that you will be getting the uh, correct answer. Means the answers quadratic so, quadratic which is solvable. You can find out the factors mostly.
Yes, the answer is 7 by root 5.
7 by root
Root 5.
7 by root 5. 7 by root 5 is 7 by 2.23. No,
Sir, wouldn't it be 0.7 meters? I mean, no, patent.
they're saying it is 4.74 meter. You may get something, but your answer should be something nearer to 4. Let me see. Wait, the time is yeah, 7, 14 by 7 root by root 5. 1.7 into 1.
Sir, I was looking the formula, like, I'm not sure I like check galat use kare. So V into root 2h by G.
Correct.
I will
That's
get 7 by root 5 if you do it that way.
no 7 root 2 by root 5. I was doing calculation in mind. Na? 7 root 2 by root
Oh,
5 you'll get.
no, sir, you'll get 2 by 10.
14 by root 10 you'll get.
Oh, sir, I got sir, समझ में आ गया सर वो रेडियस 1 मीटर दिया तो हम उसे 2 मीटर्स देंगे हाइट के इसके हिसाब से.
Yes, sir.
2 you have to take. Na?
Yes, sir.
You did the same mistake, Haripriya.
Sir,
The x should be 14 by root 10. 2 into 7 by root 10. 7 root 2 by 5. 1.4 by 2.2. 7 to 7 by 11. 49 by 11. See? Approximation 50 by 10. 5. This is less, this is more. So approximately 4.5 value. They are getting 4.7. Okay. Yeah. How I wrote this answer, because here 49 by 11, 49 I can take as 50, 11 I can take as 10, 11 I am decreasing, so answer will increase. Again, this I am increasing somewhat, it will again increase. So the answer is 5. So it's increasing by both times, means 49 I am increasing to 50, 11 I am decreasing to 10. So so I have to decrease it to 4.5. Have increased both the values. This is decreased, so answer has to be drastically increasing by 0.3 or 0.4. Okay, easy. Here to find out the x, Radhika nahi kar pai bhai. T, to get the value of x, simple thing is this is h, which is 2 meter. Time is, here you'll get time is equal to root over 2h by g, because h is equal to half gt square you'll use, and x becomes vr into t. That formula you will be using. So vr root over 2h by g, use this formula to get the answer. This is the calculation that we have. Okay. So in the next class, today we won't be able to start anything. I think no time is over. So try solving these kinds of questions so that your conceptual clarity becomes higher. These kinds of questions are good. In the next class, we'll be starting the center of mass and collision. And whenever you find doubts in solving these kinds of questions, ask me. See, if we assume this block M is not moving, then this part will become very easy. Not a problem at all. Just applying the law of conservation of energy, finding out the velocity at D, and then after it will fall down. Fine. Just using this law of conservation of energy and then using this projectile motion, we'll find out everything. But don't expect these kinds of questions to be that easy. Okay, let's end it. Next class, we'll start center of mass and rotation. Bye bye.